Good afternoon. We will see the problems that is from day 4, exercise 4, part 2. So now in this, we have this first question was asked in IS 2018. And this part already I explained. So it is given. An unsymmetrical eye section we have over there shown in figure is simply supported over 8-meter span. It carries 20 kilonewton per meter and we have to find at 3 meter from left hand A. So from A we have 3 meters. So we have taken 3 meters. So VB will get 80 minus 20 into 320 kilonewton. So this part already we have covered. I will not again repeat this one. So now we will go with y bar and I, and then we will draw shear stress distribution diagram. So we have y bar that is equal to. So now I will not explain this. You can check it. If any doubt, you can ask in the college. 60, 20 into 10 plus 20 into 150 into 95 plus 120 into 20 into 180. From center of this means we have 10 this 160 20 180 divided by 60 into 20 plus 20 into 150 plus 120 into 20. So by solving this, I got this value. Just I will check it. 1095 180. So 110.45. Then we have I and we have formula ICG plus A into H square. So now we will start with IXX equal to ICG. So we will consider first 60 into 20 cube by 12 plus 60 into 20 into 110.45 minus 10 whole square. So we have 10 value that is of y wind plus BD cube by 12 plus A into H square 20 into 150 into, now we have value 95, this value. So lesser than y, x bar or y bar, whatever you will consider. So 110.45 minus 95 whole square. And plus we have bottom flange B120 into D cube by 12 plus A into H square. Now we have this value 180. So we greater than y bar. So 180 minus 110.45 square gives us value of IXX that is equal to 30.18 into 10 raised to 6 millimeter to the power 4. Now we will consider different sections where we have to find tau. So this is 1 1 top, then we have 2 2, then we have at y bar 110.45. So somewhere here. So we have 110.45. So this will be neutral axis, or we will write 3 3. Then we have at 4 4. And then at 5 5. Now we know at 5 1 1 and at 5 5 we do not have area above and below. So we have tau 1 1 that is equal to tau 55 that is equal to 0. Now we will find tau 22. So we have tau 22, we have to find AY bar. So area we have 60 into 20 and Y bar it's centroidal distance from neutral axis. So 110.45 minus 10. And I got this value 120.54 into 10 raised to 3 millimeter cube. And then we can find tau 22. Formula we know VA Y bar upon IB. Now we have two values of B just above and below. So we have first 20 into 10 raised to 3 V AY bar 120.54 into 10 raised to 3 I 30.18 into 10 raised to 6. And then B we will keep as it is. And we will have this value equal to 79.88 upon B. And then we have tau 22 just above. Just above, we have 79.88 divided by 60 equal to 1.33 Newton per mm square. And then we have tau 22 just below equal to 79.88 and value of B we have 20. And from this we will get value equal to 79.88 divided by 20 is 4 Newton per mm square. So we will plot simultaneously so you will understand it. So we have likewise. Now we have 0 over here. First value we got is 1.33. So this is 1.33. And then we have value 4 along the same line. So we have over here 4. Now we will find next at neutral axis. So we have tau 33. AY bar first part we will take as it is. So we have that value of area 120.54 into 10 raised to 3. 54 into 10 raised to 3 plus we have to consider remaining part. Which is remaining part? This one. So what is depth of this part? So this is 90.45. And we have to add this area and its Y bar. So we have 90.45 into 20 into 90.45 by 2. And from this you will get, sorry. So we will have this, just I will rub this. So 90.45 upon 2 and we will get this area. Just I will check it. I got this area. I have not calculated, I think, just AY bar 202.35 into 10 raised to 3. 202.35 into 10 raised to 3 millimeter cube. And then we can find tau 33. Now no above below. So we have 20 into 10 raised to 3. AY bar we have 202.35 10 raised to 3. And value of I we have calculated 30.18 into 10 raised to 6. And from this, I got this value 6.7 Newton per mm. So we can plot it. That is at neutral axis. We have 6.7. So I will plot it as 6.7. Then we have at 4,4. So tau at 4,4, it is below neutral axis. So we have to consider area below it. So area below it, we have, if you will see, that this area. And that area is 120 into 20. So we have equal to 120 into 20. And its distance from the centroid. So total we have 190 minus 110.45. So 79.55. So we have this distance 79.55. So from center we have to subtract 10. So it comes 69.55. And we have this value 120 into 20 into 69.55, 166.92 into 10 raised to 3 millimeter cube. And then we have tau at 4,4, VAY bar. So V AY bar we have 166.92 into 10 raised to 3. Value of I we have 30.18 into 10 raised to 6 into B. And then we have this value into 20 to the power 3 divided by 30.18 to the power 6, 110.62. 110.62 upon B. Now we have just above of this 110.62 upon 20, and we will have 5.53. And below this, so 110.62 upon 100. Sorry, 120 we have. So 110.62 upon 120 comes 0.92. And then plot this. So 5.53. So we will have somewhere here 5.53. It goes to 0.92 over here, horizontal line. 0.92. Suddenly width changes, so my shear stress changes, and 0 over here. So all values are in Newton per mm square. So this is shear stress distribution diagram. Was asked IS 2018. Shear stress distribution diagram. Then we will switch over to the next. A beam simply supported span 6 meter, rectangular in section. So we have section is rectangular. Dimensions are given 100 by 300 mm. The maximum shear stress is given. Its shear stress diagram is simple. Already I explained in problem also. 40 Newton per mm square. It will be at center. The beam is loaded with UDL. Determine the intensity of UDL. So now we have tau is equal to VAY bar upon IB. Now tau is given 40. We have to find AY bar 100 into 150 into 75. Now we have this area, AY bar. So 100 into this is 150 and center of this 75 divided by BD cube by 12, 100 into D cube, 300 cube by 12. And B we have 100. Same everywhere. So we will have this 100 gets cancelled with 100. And then we will have value of V. Therefore, V equal to. Now you can see if you will again solve this. So we have this will be 150 into 75 into V into 12, which is denominator of denominator, divided by 100 into 300 cube. So we have 100 into 300 cube multiply by 40 divided by 150 into 75 into 12, and this value comes 800 into 10 raised to 3 newtons. So 8. So that is 800 kilonewtons. Now we have 6-meter span simply supported beam with UDL. So we are interested to find this W. So W, this is 6 meter. So V we have 3W, 3W. This will be maximum shear force, 3W, because total load will be 6W, half on this side, half on this side. And this will be V max, 3W. So equate V equal to 800 equal to 3W. And therefore W is equal to 266.67 kilonewton meter. Sorry, kilonewton per meter. We have intensity of UDL. And then third part we have derive the relation between maximum shear stress and average shear stress for the circular and rectangular section. Now for circular section. So now we have V average is tau average shear stress. Tau average equal to V upon A. So V we have and area will be pi by 4 into D square. Now tau max VAY bar upon IB. Now we have to find AY bar. So AY bar we have to find, that is the portion which is above this. And for this we have to go for this portion, that as AY bar we have to take off this AY bar. Now we will consider a small portion of this and then we will consider AY bar. So what we will get in this AY bar, that is equal to, let width we will consider as B. So we have considered this B and we will get it as 2 root R square minus Y square. Because we have X square plus Y square equal to R square. So that equation of circle we have to use. And by using that equation of circle, we have to go for this. So we have ay bar equal to 2 root r square, sorry, width that is equal to 2 root of r square minus y square. And then if we will go with ay bar, then we have integration from y to r 2 into y into root r square minus y square into dy. So we are considering a small portion this. And then we are going to integrate it. So we have this is y. And then we have this till this we have r. We have considered small width. So we have area will be b into dy. So we have area b into dy. B we have already taken and dy we know. And then we have y. This will be y bar from center to the center of this. So if you will write here, so a we have b 2 root r square minus y square into dy. This is area. And y bar we have y. And you integrate it, and by integrating, so I will directly write the value of integration, that is equal to s upon, sorry, we have this value tau. So we will integrate it and put values, then we will get tau max, that is equal to, I will directly write value 4s divided by 3 pi r square and in bracket r square minus y square. This is value of tau. And then if we will put a value of y, that is equal to r, then we are going to get value of tau, that is 0 at top. And we will put value of y as 0. And from this we will get this value equal to 4s upon, this is power 4. So if we will put y equal to 0, then we will have, so tau, here I will write tau top. So we have y equal to r, and it becomes tau top equal to 0. And if we will put bottom, then that is max, then we have y equal to 0. And from this we will get 4s upon 3 pi r square. And then we can write s means v, so 4v upon 3 pi r square. And from this we will get tau max upon tau average, and that will be equal to v upon pi by 4 d square, which is, sorry, v 4v upon, so 4v upon 3 pi r square divided by, we have v upon pi r square, I will say. So we have pi by 4 d square, d r is d by 2, so it becomes pi r square. And then we have this pi r square gets cancelled, v gets cancelled, and we have this will be 4 by 3. So for circular it is difficult, and now for rectangle it is simple. So you may have a rectangle in examination. So we have in b by d. So if we will find tau average, then we have v upon bd. Tau average is shear force upon area, and tau max. Now if I will write here, then we have VA y bar upon IB will be at center, and then we have V AY bar, we have B into D by 2 into D by 4, because we are going to consider this area which will be D by 2, and centroid of this we have D by 4, and then divided by I we have B D cube by 12 into B. And then you can see this B gets cancel. We have this D, 2D gets cancel. And this 12 will go up. So we have 12V upon 8BD. So we have 4 3s are, 4 2s are. So it will be 3 by 2 V by BD. And then we have same, we will go tau max upon tau average. So we have tau max upon tau average. Tau max we have 3 by 2 V by BD, and tau average we have V by BD. So this V by BD gets cancelled, and we have this value 3 by 2. So circular do not go, but just you should know how we will have this value. For this, we will have this one. So now we will stop here only. Thank you. So these are the two parts, that is of day 4.